Okay, so 11.2, and you notice on the agenda that it's, I don't know what I put there, but...
You put homework, 5.4 notes. Oh, no, wait, I'm reading the wrong one.
Yeah.
Day 1 questions, 11.2 and notes, homework day 2.
Was there anything with the 11.2? Like
11.2 plus notes.
Plus. Okay. We're going to do a little bit more than 11.2 because we're going to introduce matrices. Well, you've already seen them, so that's why it shouldn't be that big of a deal. So anyway, matrices. So the idea here, I don't know what the book calls the section, but the main idea here is we're focusing on systems that are larger than 2 by 2s. We're also going to do some matrices. Larger than 2 by 2, meaning you might have 3 equations with 3 unknowns. You might have a mixture like 2 equations with 3 unknowns and that kind of deal. So first, we will review the special case from before, where you have a system where the 2 lines that are given to you are actually the same line. And in this case, we said, what about the solutions? Yes. Consistent, dependent, and solution-wise? Infinitely many solutions. Good. So here's the thing I was talking about a couple days ago. We're going to be a little bit more specific. Instead of just saying, well, there's a lot of answers. That doesn't really tell us much. Okay, what we're going to say is there's infinitely many solutions of the form. So this is the part that's new that you're going to get used to. And then you're going to just write out formulas for how we can pick an x and get a y from that. So here's how this would work. Let's say this was the equation y equals 3x minus 1. And then the other one was something like 2y equals 6x minus 2. So, we graph this one. We get a line that looks like this. What's the significance of this equation? It's the same thing as that one, so it'd go right on top of it, right? Does that make sense? So, what we're going to do is this. There's a couple ways you can do it. I don't care which way you do it. For a 2 by 2 system, I would say always just write out x for the x-coordinate. And I'll explain what this notation means. And then now what you do for the y-coordinate is describe what y looks like. Well, what does y look like? It looks like 3x minus 1. How many variables do you see in your ordered pair here? 1 variable, mainly what? X. So the idea here is whenever there's infinitely many solutions, you're going to write out what the points look like, but describe everything in terms of 1 variable. Okay, so what this means now is for any x, hi. No, not until next block. Yeah. That's okay.
Please, I need her to come somewhere.
Okay.
Thank you.
Mm-hmm.
Bye.
All right, so as I was saying, what this weird notation means is that you can pick any number for x. So let's say, for example, let's pick a number, like 5. Okay? Y would have to be what? 3 times 5 minus 1, which is 14. So this is exactly what this means. This means you can pick whatever number you want for x as long as y is related to x by multiplying it by 3 and subtracting 1. which is a lot better description than just saying, oh, well, there's a lot of answers for this. Does that make sense? This says there's a lot of answers, and here's what they look like. You could have 5, 14. If you wanted to plug in 3 to get the y, you'd multiply it by 3, subtract 1. You guys get the idea. Okay? Any questions on how to work with that format? All right. So now let's look at something that we call upper triangular form. Not that you really have to know the name of the format, but something that's in upper triangular form looks kind of like this. AX1 actually, that's not what I mean. Let's start over. AX plus B1Y plus C1Z equals some other number, D1. And then for the next equation, we only have 2 variables. So let's say Y and Z. And then for the last equation, we only have 1. So it kind of looks like a triangle. It gets smaller and smaller as you work your way down. This is what the format looks like. And even though we have all variables right now, if the idea is to find x, y, and z, could you find one of these really easily? Which one?
Z.
You could find z real easily because all you'd have to do is divide by whatever that number is and you're done, right? So first you'd solve for z, and then what would you do with that? Where should you plug it in most likely?
On the second one.
And the second one, because when you plug it in here, now we know what this is, we can move it over, and then we can find y. Does that make sense? And then once we know z and y, we can plug everything into the first equation, and then we'll be able to find out x as well. Okay, and this process is called back substitution. Okay, so you find the easy one first, you work your way back up, find the next easiest variable, work your way back up, and now you find the last one. Okay, so that's what we mean by back substitution. Do we need an example of this, or can you guys handle? What's that? Oh, did you? Okay, good. All right. Let's go to another system that's larger than a 2 by 2. So staying with the bigger than 2 by 2, let's say we have negative 2x plus y plus 3z equals 6, and then 2z equals 10. Okay? This would be considered how many equations? And how many different unknowns are there? So this is a 2 by 3. You got 2 equations, you got 3 unknowns. So what I recommend doing in any scenario like this is if there's anything you can do to figure out one of them, do it. So can we find anything? Z is equal to 5. Okay. And then sticking with the motto from before, I could take z equals 5, plug it into this equation, right? So we have negative 2x plus y plus, what's 3 times 5? 15 equals 6. And now if my goal is to find out what x and y are, I can't really do that, right? Because I only have, this is the only other equation I have to work with. Does that make sense? So the best I can do is clean it up. So we have negative 2x plus y equals negative 9, right? And now since I only have one equation and I still have two different variables left, there's going to be a lot of different variables or a lot of different answers that you can plug in. Does that make sense? Like if you graph this, you know that that's a line, right? So there's an infinite amount of solutions. And then let's try to do that format that we did earlier. Of the form let's see, what do we know for sure? We have three different ones, right? Which one do we know? Z is equal to 5, so that's going to stay 5. And now this equation is what produces the fact that there's infinitely many answers because I can pick a lot of numbers for x to get y. Let's solve for y. What's y? 2x minus 9. So what this means then is that for any x, see how I'm sticking with that idea? For any x, what would y be? 2x minus 9. And then no matter what x or y are, z is always 5.
So what would that look like?
What would it look like? You'd be on a plane. Z equals 5. We're not going to spend too much time graphing three-dimensional stuff, but since you asked. Okay, there's a plane that represents everywhere where z is equal to 5, and then on this plane, if you kind of move the xy axis up and translate it up, do you guys see what I'm doing here? When you graph the equation 2x minus 9, your y-intercept would be negative 9. So down here somewhere, slope would be 2. So then this is where all your answers are. Does that make sense? It's on the line, 2x minus 9, but everything's shifted up 5 units from the xy plane. Okay? It is a little weird.
You'd have to do that?
What do you mean? Like graph it and stuff? No.
I don't know if we do it later. I'm sorry.
Settle down now. Everybody's... Are we good? Okay. Any questions on what we've talked about so far? So just to clarify, if this were on a test or a quiz, this right here would be your answer. Everything that I have there. You would say this has an infinite amount of answers or solutions, and they look like this. X, 2x minus 9, and then 5 for z. Okay? All right. Let's try one where here we go. X plus 2y plus z equals 3. 2x plus y plus z equals 16. X plus y plus 2z equals 9. This would be considered a what by what? 3 by 3. We got 3 equations, and we have three different unknowns, x, y, and z. Okay? This is the one that's a little bit more work than the others. Typically, you're going to see one answer. Okay, so this would be like 3 different planes all intersecting in one spot. Occasionally you'll have infinitely many answers, and from your experience you'll know when that is. Usually if everything cancels out when you combine equations, right, 0 equals 0 or something like that, that indicates that 2 of these are the same equation. So, but in this case, okay, here's what I would recommend. So let's write out the steps because there's kind of a lot of stuff going on here. 1. You okay, Alex? You can let him sleep. It's not funny. Number 1. Pick 2 equations and eliminate a variable. That's your first move. So for instance, and we'll walk through all the stuff we're going to do and then actually do it. So let's say I picked the first and second equation. What letter could I cancel out really easily?
Z.
Everybody see that?
Z,
Subtract it out. You get the z's to cancel out. And you have an equation with what letters left? X and Y. Good. Second step. Pick a different pair of equations and eliminate the same variable. So maybe I look at the second equation and the third equation, and if I eliminated z the first time, I'm going to eliminate z again. Okay? Yes?
So is it with the original?
Yes. 3. So after you do these 2 steps, you are now left with a 2x2 system. Because you'll have 2 equations with x's and y's in it. So solve this one as usual. And then the last step is to plug in to any equation to find the missing variable.
That's for true vectors.
Yes. Yes. Sorry. Okay, and you guys already have this, but just so we have it again, I'm going to... Ooh, I wonder if I can just tear it off real quick. Oh no. Okay. Everybody got these steps written down? Okay. No, Nathan's good. He's on Twitter or texting, so he's ready to go. Everybody else good?
How's volume?
Cold but sunny, right?
We should be fine.
Yeah. All right, so here's the system we were looking at. So let's do what we said we were going to do the first time. We said we could cancel out the z's right away, right? And all I would have to do is look at this equation and this one and subtract the 2, right? What do I get when I do that? Well, x minus 2x is negative x. 2y minus y is y, so just positive y. Z minus z goes away. And then 3 minus 16 is negative 13. Does that first move make sense?
Wait, you're subtracting?
Yes. I mean, I could do like multiply the top one by negative 1 and then add. It's the same thing. Okay? Second step is to repeat this process but pick a different pair. So I'm going to look at the second, and it doesn't matter which ones you do. I'm just doing these 2 because I can. I'm going to look at these 2 equations. If I canceled out z before, I have to cancel out z again. Otherwise, you just keep going in circles. So how would I cancel out the z here? So first we double this equation, So I get 4x plus 2y plus 2z equals 32. The second one is good, right? And now that I've gotten the same value in front of z for both equations, what could I do? Yep, subtract them again. What's 4x minus x? 2y minus y. 2z minus 2z drop out. 32 minus 9 is 23. So you guys see what just happened?
Are you recording?
Yep.
That's what
Now we have a normal 2 by 2 system. Do you guys see that? X, Y, X, Y. You guys should be able to solve that no problem, right? What could I do right away to solve? Cancel out the y's. So step 3. So now we solve what's left. So we're going to take these two equations and I'm going to subtract them because that gives us what? Negative x minus 3x is what? Negative 4x. Y minus y cancels out. Negative 13 and then negative 23 make negative 36. So what's x? X is 9. And now that I have x, maybe I plug it into this guy here. And what equation do I get now? 27 plus y is 23. So what's y? Negative 4. You guys see how this works? Now that you have x and y, the only thing that's missing is z. So, since I have this equation right here, and it doesn't matter, you can do any of the three, I'm going to go to the bottom equation, plug in x, plug in y, and then I'll be able to find z. So x is 9, y is negative 4, and then I'm adding 2z, and that's going to give me 9. 9 plus negative 4 is 5. If I subtract 5, 2z is equal to into the bottom one. So I'm just doing x plus y, so that's 9, which is x, plus negative 4, which is y, plus 2z equals 9. Combine the 9 and the negative 4, you get 5. Move it over, you get 2z equals 4. So then z is going to be 2. And now we have our one answer. The solution is then 9, comma, negative 4, comma, 2. Yes. Yeah.
I use different equations and I got different answers.
No.
But it still got, like, I plugged it back in and still gave me.
If you got different answers, that's not okay. You made a mistake. You made a mistake somewhere.
But I did one.
You made a mistake somewhere. No matter what, unless I made a mistake, it's possible, but I don't think I did. So no matter what combinations you do, you should still get the same answer. Okay, so if you want to check it out later, I'll take a look and we'll see what happened. Any questions on this? Okay, then real quickly, let's just talk about matrices. And the goal here today, anyway, is that you should be able to add, subtract, and multiply matrices.
Do you do the stacking way, or do you do like the just put it all onto one matrix?
I do not know what stacking is.
Put one here and put one above it.
Oh, no. No.
Alright.
we do it with the least amount of work as possible, which I'm sure you'll appreciate.
Does that teach how I did it?
Okay.
I didn't like it.
So here's the idea. If you have a matrix, let's say something like this, 1, 2, 3, 4, 5, 6. Okay, the dimensions, you always count rows first and then columns second. It's kind of like what we just talked about. How many equations would there be? There'd be 1, 2 equations, right? And then how many unknowns? There would be 3. That's really what this represents. Or if you just count 2 rows, 3 columns. So we'd say that this is a 2 by 3. Okay? Rows go across, columns go up and down. Okay? So as far as adding and subtracting, okay, the dimensions must be identical. If the dimensions are not the same, then you cannot do the problem. We say it's undefined. And it should make sense to you because if we do a quick example, let's stick with the 1, 2, 3, 4, 5, 6. And let's say we were going to add double of 0, 1, 1, negative 1, 2, 3. If this is a 2 by 3, and this is a 2 by 3, then our answer is going to be a 2 by 3. It's going to be the same. And addition and subtraction is very easy. Do you guys remember how we did that? Or how you guys did that?
Match them up.
Yeah, same spot. Match everything up and then add everything up, right? So here in my first row, first column, I would do 1 plus what? 0. 2 times 0 is 0. So 1 plus 0 is 1. Does that make sense? Next, if I'm matching up first row, second column, I do 2 plus, what would this become? So 2 plus 2 is 4. Next, I do 3 plus double this number. 3 plus 2 is 5. Am I going too fast, or are we all right? Sabrina, can you tell me what the last row would look like? Well, just take the matching spots and add them up. So what spot is in the same as 4 over here? Or what number is in the same spot? So it's 4 plus, but the 2 is going to double the negative 1 first. 4 plus negative 2, and you get? Yep. Does that make sense? That's all you do. So then we do 5 plus double the 2. What is that? 5 plus 4 is? 6 plus double the 3. So 6 plus 6 is 12. So this would be our answer. Good?
Or you can just plug it in your calculator.
We'll talk about that later. But yeah, you're going to have to know. You're going to have to do by hand and with the calculator.
But it's a lot of work on the calculator.
It is. Like something like this, I would not waste the time to do because it's not worth it.
You gotta get one.
Okay, to multiply a matrix with the matrix. I'll just tell you again the rule, and I'll explain why that rule makes sense. So let's say you have an A by B matrix times a B by whatever, C. these two numbers right here, the number of, what would this represent, a column or a row?
Column.
So the number of columns in first matrix has to equal what? The number of rows in the second matrix. If that does not match up, then you cannot do it. And you'll see as I explain and review with you guys how we multiply matrices, why that needs to be the case. Okay? So here's an example. We'll start basic. Let's say I have 1, 2, negative 3, 0. And I'm multiplying that with 1, 2, negative 1, 0, negative 4, 1. Okay? What are the dimensions for this first matrix? 2 by 2. And the dimensions for the second matrix? 2 by 3. Do the number of columns equal the number of rows? So this is good, right? Now, the other thing that I haven't mentioned yet, these outside numbers give you the dimensions of your answer. So we know that we're going to end up with a 2 by 3 matrix. All right, so now here's how this works. Make sure you're paying attention because it's going to get a little tricky.
I think my way is easier. Just gonna throw that up there.
You take first row and you distribute it to every column. And here's what I mean by that. And you do first number times first number, second number times second number, and you add them up. So 1 times 1 is 1. And then what's 2 times 0? So that, whatever that is, that's the first number. And then you repeat, go on to the next column. 1 times 2 is 2. 2 times negative 4 is negative 8. Can anyone tell me what the last one would be? Negative 1 plus 2. Very good. Does everybody see how we're getting that? You take the first row, distribute it to each of the columns, like so. You're going to add these up eventually. Once you do that, you are done with this first row. You ignore it. Now you go on to the second row, and you repeat the process. So what's the bottom row going to look like? First number times first number, negative 3. 0 times 0, 0. First times first, negative 6, and then plus 0. Negative 3 times negative 1 is 3. 0 times 1 is 0. So our answer would look like this. 1. What's the next one? Negative 6. 1. Negative 3. Negative 6. 3.
I gotta show you my way.
I'm interested.
Yeah. I was in my class and I taught the class. That's pretty cool.
Do you guys kind of see how we'll review it again? Yes, go ahead. Shh. Bottom right be negative 3.
Yes.
It should be...
Yes.
No, we're good, because negative 3 times negative 1
Oh.
is positive 3, and then...
Are you still recording?
Hey, yeah, get out of here.
Oh.
Ruining my lights. Nathan, that makes sense? Okay.